All right, so we're going to go over some enrichment problems. If you are watching this as an online student, then what I recommend is looking at these problems and pausing the recording, trying it for yourself, and then resuming the recording. So here's problem number 1. List the possible sets of quantum numbers, including m sub s, that would produce a 3D orbital. And here's problem number 2. Is this a valid set of quantum numbers? So for each one of these sets of 4 quantum numbers, you decide, is it valid or not? And then if it is not valid, tell me why. So here are the first several. So there's the first sets. And there are the remaining ones. So again, if you're watching this as an online student, I recommend pausing the video, trying it for yourself, then resuming the video when you're ready to see the answers. So now, for those of us on campus, I'm going to go over these here in class so that everybody has the right answers, because this will be on the final exam. All right. So, set of quantum numbers includes 4 numbers, right? They are n, l, m sub l, and m sub s, right? You have to have all 4 of these for it to be a set of quantum numbers. Let's review what n is. Now this is 3D, right? So n equals what? Well, for 3D, n equals 3, yes. But what is n? N equals size, right? What's L tell us? Shape, right? M sub L, what does that tell us? I think you were just about to say it. It tells us what? Orientation, right? And M sub S tells us what? Spin. All right, so for a 3D orbital, n equals 3, and how do you know L? You should have this little chart committed to memory, right? There are 4 values of L that we're responsible for. What are they? 0, 1, 2, and 3. And what did they correspond to? S, P, D, and F. So if this is a D orbital, then the value for L in all these sets needs to be 2. Okay, so now we just need to remember our rules. For m sub L, what are the rules for m sub L? M sub L ranges from what range? Negative L to positive L, right? So in this case, that'd be negative 2 to positive 2, right? And m sub S can only ever be 2 values, which are what? Plus or minus 1/2, right? Okay, so let's go through these sets for a 3D orbital, see if we can come up with all of them. Okay, so n equals 3. What must L be? We already defined that, that's 2. Now m sub L is going to range from negative 2 to positive 2. So we can have 3, 2, negative 2, and then what's possibility here? Positive 1/2, right? Can you have this exact same set with negative 1/2? Yes. So 3, 2, negative 2, negative 1/2. What's another set? 3, 2, what's another value of m sub L that would work? Negative 1. And then we'll just need both options for positive 1/2 and negative 1/2. All right, what about 3, 2, what's another value of m sub L that would work? 0, positive 1/2. 3, 2, 0, negative 1/2. What about 3, 2, positive 1? Would that work? Is that valid? Yep, that falls within that range. Positive 1/2. 3, 2, 1, negative 1/2. And then there's one last. Which one would it be? 3, 2, what? 2. And then positive 1/2. That's a 1. And 3, 2, 2, negative 1/2. All right, so you have 10 sets. What if I said to exclude m sub s? So let's just simplify things, exclude m sub s. how many sets would you have then? You just have 5 sets, right? If we excluded M sub s, you'd only have 5 sets. Or because we're including M sub s, we have 10 sets. Does this make sense? Did you get them all? Get all 10? If you didn't, do you see where you made your mistake? Because it's just applying our rules. All right, let's go over the next one. So now we're applying those same rules. Now we are looking at a set of quantum numbers and asking ourselves, is it valid or not? So let's refresh our memory. There are restrictions, written it on my page here, so I'm not trying to read off the screen. There are restrictions, right, on certain things. What is the restriction on N? This, by the way, when it got chopped off, there's N, L, M sub L, and M sub S. There are restrictions on N. What can N not be? It can't be 0, right? And it can't be negative either, right? That's assuming. It's got to be greater than or equal to 1, right? There is a restriction on L. What's the max value? L is all numbers up to what max value? N minus 1. Okay, M sub L must fall in what range? Negative L to positive L. And M sub S can only be 2 numbers, plus or minus 1/2, right? So we've got to apply these rules to these sets and then ask ourselves, is it valid or if it's not, or is it not valid? So is this a valid set? If N is 1, can L be 0? Yes, that's allowed. If L is 0, can M sub L be 0? Yes, that's allowed. And is that a valid M sub S value? Yes, so this is a valid set. No issues with that problem, with that set, excuse me. All right, let's do the next one. If N equals 1, can L equal 1? No. Why? What's the max value of L? The maximum value of L is N minus 1, right? So this is not valid. So the max value here would be 0. And so if this is 0, could M sub L be 1? No. That's a valid value of M sub S, but this is a set is invalid. No. Max value of L is N minus 1. Right? Can't have N minus 1. Can't have a value of L that exceeds N minus 1. 2, 0, 0. Negative 1/2. Is that allowed? Well, let's see. If N equals 2, the max value of L is 1. But could it be less than N minus 1? Yes, that's allowed. So this could be 0 or it could be 1, right? That would still be okay. If L equals 0, can M sub L be 0? Yes, that's okay. Is that allowed for M sub S? Yes, that's fine. All right, what about 2, 2, negative 2? No, what's wrong? Right, if N is 2, then L could be 1 or it could be 0. It could not be 2, right? Because the max value is N minus 1. Therefore, that means this answer's out too. So both of those values are garbage, right? No, for the same reason here. Max value of L, N minus 1. Do we agree? If we have 2, 1, negative 1, if N equals 2, can L be 1? And if L is 1, can M sub L be negative 1? Yes. And can M sub S be positive 1/2? Yes, that's a valid set. You're allowed to have that. What about 3, 2, negative 1, positive 1/2? If N equals 3, can L be 2? Yes, because that's less than 1, right? That's less than n minus 1. If L is 2, can M sub L be negative 1? Yes, because it's in the range of negative 2 to positive 2. That's within that range, so that one's good. And that's a valid value of M sub S. So yes, that one is allowed. All right, I'm going to erase this and move the page up a little bit. Which one do we do? 3, 2, negative 1? Okay. Let's move it up. 3, 2, negative 1 was what we just did. All right. If n equals 3, can L be 1? That's allowed. If L is 1, can M sub L be 0? Yes. Is that a valid value for M sub S? No, that's where things went wrong, right? No, this is not valid. M sub S is equal to plus or minus 1/2 only. Right? M sub S cannot be 0. All right, let's look at the next one. If n equals 3, can L be 1? Be 0, excuse me. Yes. If L is 0, can M sub L be 1? No. Why not? What's the only value that M sub L could be? 0. If L equals 0, then M sub L is 0 as well. So, because we just corrected this one's pretty easy. Is this a valid set? 3, 0, 0, negative 1/2? Yes, that's allowed. And then the last one, 1, 2, negative 3, 1/2. If n equals 1, can L be 2? No. And if L, what could the value of L be? Only one value could be 0, which means this value's out as well. Right? If n equals 1, then max value of L is 0. How do you feel about these? Evaluating a set of quantum numbers and deciding valid or invalid. Questions on any of these that we need to address? All right, that's where we'll stop. And I will see you on Wednesday.